Welcome to section 5.3. Yay! Okay. Okay. And this is going to be the third method of solving systems. Now, I'm going to be very honest with you. This is probably the best method to solve for any system that you are going to be working with. And especially when you have story problems. This is the best method to deal with story problems. And you are going to see in the next 8 slides how to do this. Now, again, I always give you a series of steps to follow in case you are first learning this and you need some information as to how to move along. And we're also going to talk about some special cases that you're going to see. And in the process of elimination, these make life pretty easy. And then we're going to use substitution to solve or check your ordered pair. This is the best way to ensure that you never have a mistake. Well, let's go to the steps. Well, the first steps is that you must write each equation in what they call standard form, which is ax plus by equals c. Now, you're going to create columns and try, as the columns are written, to eliminate a column containing either the x or the y term. Now, that means one x or y has to be positive and one x or y has to be negative to eliminate them, because we're eliminating columns that add to 0. And to do that, I've got to have opposite signs. Now, if a column cannot be eliminated, we're going to place a blank in front of the equation, and I'm going to show you how to use that blank. And that blank is going to have a multiplier that's going to allow you to multiply, and this is the key, all terms in the equation so that you can eliminate either x and y during a second go-around. Now, once we get an answer for one of the variables, we're going to use substitution to get the other variable. And then, because we have two equations, we're going to use the other equation that we don't get our second variable from, and we're going to see if it checks. Now, 5, 6, and 7, if I show you, it's a lot easier to do. Also, with the blank in step 4, it's probably easier to show you than it is to tell you. So here we go. Okay, first off, it is asking us to use elimination. Well, right away, we are going to create columns, which means this is my yellow column. This is my purple column. And then I have this lovely pink column. Okay. Now, some people actually like to write it a little bit more perfect, which is this plus I have 4y, y equals -1, 6. This is the columns I'm talking about. This is my yellow column. This is my purple column. This is my pink column. Now, if you look at the yellow column, I have a -1 1x, and I have a positive 1x. Well, you're going to notice that if I add those columns just as they stand, they eliminate. They equal 0. Now, what's left is I add the other two columns. This will give me 5y, and the reason is I have a 1 here. And remember, I don't write ones, just like I didn't write that one or that one. And then on this side, I have a positive 5. I'm going to divide by 5, and I get y is equal to 1. Okay, now my choice. I then come back to this first equation because I have to find x. Well, this will give me a negative x plus 4. Now, where that y is, I'm putting a 1, and this is equal to negative 1. This will give me negative x plus 4 is equal to negative 1. Subtract 4, and notice I get a negative x is equal to a negative 5. But remember, I'm dividing by negative 1. So my answer right now is the x value, which is positive 5, 1. This is my xy. This should be my solution. But just to make sure, you see this equation right here? Okay. This one that says x plus y equals 6. Well, I'm going to come here and write 5 plus 1. Does it equal 6? Yes. This is my answer. 5, 1. Well, let's try again. Okay, now this one, not nice. If we look at the x's, if I add them just as they stand, I get 5x. I didn't eliminate anything. If I go to my y's, which are right here, I happen to have a positive 4y. I didn't eliminate anything. Okay, this is where the blank comes in. You are going to put a blank in front of both of these equations. Now, do you need both of them? No, but you put them just in case. Now, if we look at the x's, I have two positive numbers. Well, remember, to eliminate, one must be positive, one must be negative. So that means I'm going to go to the y column. Now, I have a positive 5 and a negative 1. Can I make that negative 1 a 5? A negative 5y? Yes. So I'm going to put a 5 up here, but I'm not changing anything here. So that means this 5 is multiplying by each term, which gives me 15x minus 5y is equal to negative 20. Well, the bottom equation is not changing. It stays 2x plus 5y is equal to 20. Okay, I'm making columns. Now, this is going to give me 17x. But notice what happens here in my purple column. Okay. This column, positive 5 and negative 5 are going to eliminate. And notice I cross them out. They equal 0. But be careful. This column also equals 0. Now, when I divide by 17, this x is 0. That x is 0. Well, now I'm going to take that 0 and come to 3x minus y is equal to -4. And where this x is, I am going to write 0. Well, as we know, 3 times 0 is 0, so that's canceled. -y and a -4. Well, now I'm going to divide by -1. And my answer just happens to be, I'm going to put it up here. Now, x always goes first. Y is going to be a +4. Now, this is where you come to the third equation. Where that 2 has an x behind it, I'm going to put 0. And where that y is, I'm going to put the 4. Now, I do agree some people can do this in their head. That's okay. But I would suggest that you do check it. Because why make a mistake if you can ensure that you don't? Well, this is going to give me 0, and 4 times 5 is 20. So my answer is 0, 4. This is x, this is y. Okay. Now, let's try again. Okay, this is where you have to understand that step 1, ax plus by equals c has to be done. And if you look at this first equation, it's not written in that form. So I'm going to write a -4x plus 7y is equal to -1. And I'm going to put 6x plus 2y is equal to -11. Well, as these equations sit, if I do the -4x and the 6x, I'm going to get 2x. I haven't eliminated anything. If I look, and by the way, yes, that is a y. Sometimes my y's come out like 4s. 7y and 2y is 9y. That doesn't help me. I have not eliminated anything. Now, this is where that blank is going to come in both equations. Well, this time we're looking at the x's. Now, if you look at the x's, one is negative, one is positive. So therefore, this is what I'm going to do. I'm going to put a 6 up here and a 4 down here. The reason is I have a negative and a positive term. All I have to do is take the numbers, because the signs are already set for me, and this will give me a -24x plus 42y equals -6. This 6 must multiply by every term. But I also have to take this 4 and multiply it by every term. Now, this is going to give me a +24 plus 8y equals -44. Well, as you can see, these x's are going to cancel. They equal 0, which means I have 50y equals negative 50. Divide by 50. I get y is equal to negative 1. Well, now, this is where we have the fun. We know why. Okay? So what we're going to do is we're going to take this value and go to the first equation. Now, I'm going to the first equation, but I'm going to go to the next slide so that I have all the room that you can see. Now, this is going to give me 7 times negative 1 equals 4x minus 1, negative 7. Now, if I add 1 to both sides, I get a 6 is equal to 4x divided by 4. Now, remember, you've got to reduce this fraction. X is equal to 3 halves. Now, notice x. Well, remember, we have this other equation that's 6x plus 2y is equal to negative 11. That means this 6 is multiplying by 3 halves. Remember, I'm going to cross cancel. This will give me 9 plus, okay, oh, get me. I was going to find out that I made a mistake. And that's where when you check it, because see, this would have given me a negative 6. Forgot to bring the negative down. That would find out right here in this check, because if I put, that's why this check can be real important. So my answer is negative 3 halves, negative 1. This is my x, this is my y. That's negative. So see, the check does have its purposes. Sometimes you make just a little silly mistake and you blow the whole problem. So therefore, why make a mistake with these? You can always check them. Now, we're going to go to this one. Okay. Now remember, ax plus by equals c. Well, look at this equation right here. It's not in that form. So here we go. We're going to write 4x minus 2y equals 7. And I'm going to get a negative 6x plus 3y equals negative 1. Okay, hopefully you now recognize that I cannot eliminate a column. Positive 4 and negative 6 is giving me a negative 2. A negative 2 and a positive 3 for y is giving me a negative 1, which means I'm throwing out in front a blank. Now, the beautiful part is you can make a choice. Both my x and y have a negative coefficient and a positive coefficient. But the key is the easier one is the y's, because the numbers are a little smaller. So I'm going to put a 3 up here and a 2 here. I don't have to put any positives or negatives with those 3. I just have to take the numbers. It's already set me up because I have a negative number and a positive number. Well, here we go. This will give me 12x minus 6y equals 21. I then have a negative 12x plus 6y equals negative 2. Now notice what happens here. These 12 eliminate, but also these 6's eliminate. I have 0 over here. This eliminated and this eliminated. But I have a number over here. 0 does not equal 19. This is a no solution. You don't have to go any further with it. It's done. Or sometimes they put the 0 with the slash through it. If both x and y eliminate, and you have a number on the other side, then you have a no solution. Okay? Now, we got 2 more to do. Let's take a look at this one. Okay, now, this one is not a nice one because we got to get rid of the fractions. Okay, plus we also have to have ax plus by equals c for this equation. Well, first off, both fractions have a 5, so life is going to be easy. 5y is equal to 3. I multiplied every term by 5, common denominator, my LCD. Now, I'm going to take and write 12x plus 10y is equal to negative 6. But then I'm going to write 6x plus 5y equals negative 3. Okay, this, as you see, my columns. The x's are going to give me an 18x because 12 plus 6. I'm going to put blanks here, but I'm not going to do anything with the top one because if I multiply the bottom one by negative 2, because remember, I have to have opposite signs to eliminate. So that means my bottom row is the only row that's changing. The 12x plus 10y is staying negative 6. But notice what happens when I multiply negative 2. I get a negative 12x minus 10y plus, don't forget, I got it right here. This is the negative. This is going to give me a positive 6. Now, this is where you have to remember, this column eliminates. This column eliminates. But what we're also seeing is this column eliminates. This is 0 equal to 0. Now, this is infinite or many solutions. Now, Well, remember, this is set notation. This is x comma y such that. Now, we're using the intercept form. This is y equals negative 6/5 x minus 3y, and this is my answer for infinite many solutions. Okay. This slide, I want to let you notice we used, in this particular case, substitution after we got one of the letters. Sometimes you can use this process of elimination twice. And when you have fractions that are not so nice, it's easier to do it that way. I can't always guarantee you that I like it, but it does happen. Now, first off, if I look at the x's, they're going to give me 7x if I add them together. The second column gives me a positive 4y, but I still can't eliminate. So what I'm going to do is I'm going to put this blank out in front, and I'm going to go for the y. I'm going to put 7 up here. I have opposite signs. I don't have to worry like I did in the last problem. I had to choose a negative multiplier because both my x columns and y columns had two positive numbers. Well, this will give me 35x minus 21y equals negative 42. This will give me 6x plus 21y equals 3. Now you're going to find that these fractions are not very nice because, as we just found, this is going to eliminate. This is going to give me 41x is equal to a negative 39. So when I divide by 41, this fraction is not a nice fraction. Okay, but you can take it back to the first equation and work with 41s. It'll also work that way. But this is telling me that x is equal to 39 over 41, and that's a 9. Okay, and that's a negative. Now, you can do it a second time. I normally don't like to. I would prefer to take this and put it in my first equation and solve for y, but then I like to work with fractions. Some people don't. And because they don't like to work with fractions, they like to do elimination twice. And I'm going to write it here. Using the elimination method twice. Well, I have here the 5x minus 3y is equal to negative 6. I have the 2x plus 7y is equal to 1. Well, we got rid of the y's. Well, this time, when I do the elimination method, I'm going to put the 2 up here, and I'm putting a -5 at the bottom because both of my x's are positive. Now, this is going to give me, okay, I'm going to get 10x minus 6 is equal to -12. I have a negative 10x minus 35, and I forgot to put the y behind my 6 here. And this is going to equal, in this case, positive 5. Negative 5. Okay. Well, as you see, these are going to eliminate. This will give me a negative 41y is equal to negative 17. Divide by negative 41. Y is 17 over 41. Now, we did elimination twice, but I always find it's better to check it because this system, my 2 answers of x and y are correct. X is negative 39/41 and y is a positive 17 over 41. Now, this is going to give me, now, I am taking 5, and I'm going to put here my negative 39 over 41, and then I have a minus 3, and remember, I got 17 over 41. That's a 17. Let's make that a better 17. Now, this is negative 6. So 6 times 41, because I want a numerator up here, is going to give me 6 to 46. I make this 6 an improper fraction. I put a 1 under here, and I get 41 here. Multiply 41 times 6. Now, why do I want to have 41s? Well, 41 is here. 41 is here. Why not have common denominators all the way across? Well, let's check this out. I'm going to have 5 times negative 39 is 195 over 41 minus 51 over 41. What do these 2 numbers equal? That checks. That's why I made this negative 6 an improper fraction. So that means I only have to work with fractions that are nasty one time when I check it, or you have to believe that you did something correct. This is a negative 39 over 41. This was my x, and I have a positive 17/41 for my y. Because I checked it, I know this answer is correct. But instead of using 41 3 times, which I could have done, I used it only once to check. So your choice. I prefer to use fractions all the way through. Fractions that you really don't like, such as this answer. Well, that now ends our wonderful section 5.3. Yay! Enjoy.